Hey, it's great for me to be here. It's an honor and a privilege. Thank you all for coming. It's a big house, and I'm glad that I can see you. Hopefully, I'll keep you awake for the next 35 minutes or so as we talk about some things that I hope you enjoy. So I've been thinking about what to chat with you about, and it's been interesting when you get to be an old guy like me and you start talking with some of your friends, and they think about, oh gosh, in my career, if I had to do it over again, I'd do A, B, and C differently. And I've thought about, in my career, I don't think there's a thing I do differently. I've had a huge amount of fun as an engineer. And I probably spent not that much time really doing engineering, but engineering-related activities, and it has been a hoot. So as I was thinking about the topic today, I thought I'd share some lessons learned from my perspective on how to have a whole lot of fun and get a lot of fulfillment out of your engineering and technology degree. And I'm going to talk about success, right? But I'm going to define success as fulfillment. People define success lots of different ways, but I think for you, as you think about your career and what you want to accomplish, you want to think about your goals, what those goals might be are going to be varied. The contribution you're going to make to humanity, the way you provide for your family, the challenge that you address, and the way you are able to accomplish those objectives will define as success. So with that, we'll just kind of dive into it. First, congratulations for deciding to be an engineer or technologist. I think that's great. Everybody pat yourself on the back, right? Did a great job. Because frankly, how many people can really have the aptitude, right, and the ability to do engineering and technology, right? There's not that many people that can do it. And secondly, how many people really have the work ethic to pull it off, right? Because it takes a lot of work. So, you guys did great. It's great just to be here, and congratulations. And I think about, I've got kids that try to get into BYU. Some of them have been successful, and some of them not so successful. So I look at how hard it is to get in, and I think I'd be kind of on the borderline of being able to get in here. So most of y'all are smarter than I am, and got huge futures ahead of you. But you think about being an engineer, and I just want to spend a little bit of time. We'll have a little bit of fun in the beginning here, thinking about who some of the really amazing engineers are, and what great company that you're in. Okay. So you think about, and I guess the other fun thing I get to do today is there aren't very many venues where you get to talk about sort of profession and religion and mix the two together. So we'll do a little bit of that today too. Hopefully have a little bit of fun and enjoy it. So here's the first one. How about this? We all know who this picture is, right? This is Lehi and Nephi getting around. Ever think about Nephi as being a fellow brother in engineering and technology? Think about what that guy had to do, right? First he's a geologist because he had to go find the ore to make the tools, right? He had to make the tools, had designed the boat, right? Lots of structural engineering work going on there, a lot of manufacturing, some guidance and control mechanisms, right? So a lot of good stuff that he had to do as a fellow engineer. How about this one? Think about Noah and building that ark. I know a lot of you, there's a facilities management program here at BYU. Think about managing that facility. Think about the waste management involved in there. Just the HVAC, right? Just making sure you had some air to breathe going on. Put aside, right, all the structural design work and all the dynamics that required, all the load analysis that had to get done to make that arc work, right? And of course, I think the master engineer of them all, I think we're all in great company, is our creator, right? Obviously did some great work creating the worlds, but they talk about him as a carpenter. I personally think that back then, those were the engineers, right? And I think that we talk about carpentry and we think about maybe making this and that. I'll bet you he put together some pretty amazing devices, right, as a carpenter back when he was around. So I also think we can take our Savior as part of our engineering brotherhood, right, and aspire to that. So congratulations to all of you. So the next point I want to talk about, in addition to just doing a great job, is what it takes to really be a good engineer. You're all very, very smart. You wouldn't be here. You're all very, very hardworking. You're likely ambitious. But it takes time to learn our craft. And it was kind of a surprise to me when I got out of engineering school. I did well. I worked really, really hard. And I was like, man, there's a ton of stuff I didn't know. I was really shocked. And I kind of, almost in a daze my first year I was working in the Phantom Works of a large aerospace company doing advanced design work. And there was just a ton that those professors at BYU didn't teach me, okay? So realize that when you get out of school, there's still a lot to learn, and you got to learn your craft. And there's a lot that goes in, right, to the engineering craft, and part of it is the engineering design process. There's just certain things you have to do to make to build complicated systems and to make them work right in a multidimensional and in a wide range of environments. And I've learned that, gosh, many, many times. I've worked in large companies. I've done startups starting in my living room. I've walked into startups. I've been recruited by venture funds to run some of their startups. I ran a startup that had been the brainchild of 4 Stanford grad students. And they walked out of Stanford, put the startup together, started trying to build a company. None of them had any work experience. And after a year, they had some great ideas, but after a year, it really struggled because they didn't really understand the complexity of their craft. So I want you to think about that and be a little bit patient about once you go. So I'll give you a quick example. So I was working at this startup, 50 brilliant software engineers, and we could not get a good software release to work. We were using the agile software development process, going through sprints. They didn't work at all, right? And so we sat down and said, okay, what process are you using? And are you using the agile process effectively? And we realized that they had some shortcomings. They were taking too many shortcuts. So we cleaned all that up. The next process, guess what? The release was perfect. I mean, everything was seamless transition, met all of our objectives. Get ready for the next sprint. 6 weeks later, software release, outstanding, worked perfectly. We were like, okay, I can start focusing on other challenges within this company, got software down. The third release would come around, it was another disaster. Nothing worked. Didn't meet any of the objectives, it was buggy. So we said, okay, let's sit down and find out what happened. Well, we dug into it, and what we found was all of our brilliant engineers figured, hey, the last 2 releases went so well, let's just ditch this cumbersome process and let's go back to the way we were doing it before because we're so smart and we can just skip all these steps, right? Well, clearly that didn't work. And as engineers, there's a process that we have to follow. And here's what I think is kind of fun. What I've realized is that about the best engineering process that I've ever seen is actually in the scriptures. So it's in the design of the world. So if you read through Genesis, Moses, Abraham, and even the temple, right? You learn about the creation. That is the perfect engineering process, and I kind of want to walk you through that a little bit to get you excited about embracing your craft, okay? So first off, you got to have a detailed plan. A lot of engineers like to dive into something, they start to build or whatever without really thinking through all the elements. And a lot of those elements are things that are maybe even more important sometimes in engineering. It's like, what's the budget going to be? What's the schedule going to be? How am I going to build this thing? Okay, after I build it, how am I going to maintain it? Is it going to operate in all of the environments in which this thing has to function, right, to be successful? A lot of products that have been designed, were really great ideas, but the execution was atrocious because they didn't do the early design. So we learned in the creation that, right, everything was done spiritually. They did a design before they actually built it. What's the second thing they did? All right. They counseled together amongst themselves. They got a lot of feedback. Engineering is a collaborative process. One thing that engineers we were used to doing is like doing an analysis, right? Getting an answer, putting a circle around it so the grader can go check, you got that right? That's not really how the real world works. There's so many different dimensions, and in many ways, there's not one particular way to solve an engineering problem. It's design, it's art, and you need to collaborate. And you need to collaborate with your peers, but I also strongly suggest that you find mentors that you can work with because much of what you need to know out in the engineering environment, in real life engineering, is not even taught in schools and sometimes not written in books. There's an art to it, and smart people have been there before you, right? And you want to take advantage of those experiences that they've had. Call them ankle bites. They've been bit around the ankles and made lots of failures. So build on their successes, right? And seek out and don't feel threatened when someone wants to come in and kind of watch what you're doing and see what you're doing. Take that actually as positive, and it'll help you be a smarter person. Okay, so seek constructive input from others. Frequent return and report. Okay. It's the other thing, engineers are sometimes really reluctant to share what they're doing. They want to get it all done and show that finished product, right? And part of the engineering process is having milestones where you get so far and then you stop and you take a look and you say, hey, how am I doing? Is this the right thing to do? They're kind of return and report based on some process that they've gone to. In some formal design process, you've got like a preliminary design, you've got critical design, you've got integration design, a number of these formal reviews that are important, and you can define them however you want, but you want to create milestones in your design process where you're making sure that you're on the right path, you're talking to your customers, you're talking to your boss, you're talking to your coworkers, hey, am I on the right track? Return and report. You want to do that often. And then the other important part in engineering process is start with the small steps and make incremental progress. Think about the creation, right? The fun thing would have been, hey, let's go create the human because that's the challenge. Let's go do that first. Well, if they had done that, there may be no world for them to walk around on. Or if we got the world built, let's build that human. Yeah, but then we forgot about the grass and the plants and the food for that human to eat, right? So there's a logical step you need to think through, okay? And the other thing you realize in some versions of that creation, on the first day, they did one thing. The second day, they did two things. Third day, they did three things. They got increasingly more complicated. And I think that day when they talked about doing plants, I don't think they designed that giant sycamore first. I think it was the blade of grass came well in advance of that, right? And they then went and built, designed and created the animals, right? And I'm sure they started with, the ants and some of those small ones. They get those kinematics down before they got a little more complicated. So as part of that engineering process, it's good to start simple and build, right? And do incremental development. Learn as you go, right? Think about the creation of the human, right? So hey guys, we are human 1.0. Let's just get real about that. Right? Once we got the male human down, then they decided to do a major hardware upgrade as well as a very significant software upgrade, okay? And we all know how that works. But very, very clear in the creation of the world that that's the way it needs to happen. Stop on occasion and admire your work. There's an awful lot of challenges that you face, and especially as engineers. I have my good friend Carl Baldini. He's an electrical engineer, and he's kind of always got this little cloud around him because he's always thinking about what can go wrong, right? Because as an engineer, you design for those edge cases. You want to make sure you have plenty of contingency in what you're doing, and you get focused on the problem of the day. And sometimes you don't step back and say, hey, look at all the great work that I've done. Look at the accomplishments so far. That's important in just your mental health as you're doing design work and as you're building. Edison he'd say he'd have 100 failures before he had one success. So you got to kind of, when you have those successes, have a party. Enjoy it and kind of look around and say, hey, this was the right thing to do, and look at the progress we've made. The last important step, in this engineering creative process, get some rest, right? We know on the seventh day they rested. Well, you're going to find rest is going to be an important part of your development and creative process. Early in my career, I pulled some all-nighters. Had some deadlines and had to work through the night, and diminishing returns. Eventually, you're getting like virtually nothing done. And then I kind of realized that wasn't very effective. Later in my career, I get to the point where I'd say, you know what? I think we've done about as much as we can do. Let's just go home and sleep on this thing. I'd go for a bike ride. Some of my coworkers would go for a run, and let's come back and address this in the morning. Get some sleep, come back in the morning. For some reason, the problem, you had a whole new perspective. Many, many times on bike rides or even in the morning in the shower, like, that's the solution I needed, right? It happens a lot. So I would seriously factor in this whole idea of getting an appropriate amount of rest to give you the perspective that you need in solving some of these challenging problems. So, just interesting you think about it. I've worked with a number of large companies. I've worked with small companies. Sit on the board of a number of venture-backed technology companies. I chair the technology board of a venture-backed company. And I've put in place engineering processes many places, and I always use this one, okay? So think about that. And as you are sort of studying the creation, think about how that can benefit what you're doing in your career. Because you know what? We can be as smart as we want and have as much insight as we want into how to change the world. But if you can't turn your vision into something tangible and make it work, it's hallucination. This is a great quote that I've given lectures on this topic alone, okay? But ladies and gentlemen, vision without execution is hallucination. And in order for you to really get a lot of satisfaction out of your career, learn your craft, okay? Get good at it. And it takes some time. You're going to come out of college and you're surprisingly little. I didn't know quite as much as I thought I did. All right. Point number 2, or number 3, I guess. You can change the world, right? There are so many things going on in this world that are changing, that are directly related to engineering and technology. We are at the inflection point in so many areas that you're just on the cusp of just great things happening, and you have the ability to really have whatever impact you want to have. There's a book, and I'll talk about a little bit later, by Malcolm Gladwell called Outliers and the Key to Success. He talks about the fact that working really hard is important, right? And having some ability is important, but a lot of it's just luck. It's people that have really had a huge impact on the world who just happen to be born at the right time. And look, ladies and gentlemen, you guys are born at the right time, and it almost doesn't matter what you want to do. You are in a great time. We'll talk a little more about that. So I like to read The Economist magazine. A little bit of British humor, right? This is a cover from The Economist magazine in 2013, and it was an article, or the focus of the magazine that was on innovation, and they were reflecting on the fact that so much investment was going on in social media. Is that really affecting, the quality of life? And are we ever going to do better than a toilet? And you think about the impact the toilet had. It was pretty substantial, right? But they go on to say in the article and in the magazine in general that indeed we are at an inflection point in virtually every element of engineering and science. Think about the recent the guys that won the Nobel Prize in physics. You guys know what they got that in? What were they able to measure? They were able to measure or to show that there's a gravity wave, right, and prove the existence of the gravity wave that was predicted by Einstein's theory of relativity. Well, imagine the changes that are going to occur in the world when we can control gravity. I mean, that's what the Swedish Academy of Sciences said when they awarded these guys the prize, is that there's just endless amounts of change that are good that's going to happen. Massive inflection point. I love this one. It's another cover from The Economist magazine. Look, the 20th century was defined by the internal combustion engine, right? There was combustion programs at BYU when I was a student, right? And it's roadkill at this point. I even recently heard an article by the founder of Dyson, the guy that does the vacuums and the hand blowers, right? He's putting $2 billion into an electric car. So think about it, virtually anything that you're excited about, it's an inflection point. Here's another one. So President Eyring in his conference talk in April, you caught that? He said, it's really the internet and the power of the internet that has enabled the tremendous increase in our ability to do family history, right? All of you in computer engineering and IT out there, IT technology. He said one of the sales guys that came in to try and sell the church some computers, he goes, when he realized what the church was trying to accomplish, he says, oh my goodness, now I can see why computers even exist, right? And President Eyring went on to say that, look, the technology the church actually ended up picking hadn't even been invented yet. But you think about all that's going to happen to kind of prepare the earth for the second coming, all the communication technology, the ability to share the gospel with everybody. Technology is going to be the key. And again, a very, very important inflection point. I mentioned that the Malcolm Gladwell story, pitched by Malcolm Gladwell. He said that success is not just hard work, but rather it's a gift. And again, defining success as fulfillment in your career, right? You have to be born right place, right time. And I think all of you are fortunate enough to be born at the right place, right time. All right, let's move on. So point number 4, you get to play with cool toys, right? And I think that, I hope that that's something that you're excited about and that you can be passionate about. And define cool toy any way you want, right? One of your speakers here a couple years ago, a friend of mine, Phil Carmack, Phil led the development of the chipset that we used for the displays on the Tesla Model S, right? And so he got to work through all that, but most importantly, he was one of the first guys to get a Model S. So he was cruising around Silicon Valley. We were living up in Palo Alto at the time, but he was one of the first guys with a Model S, and that was pretty cool. Another good friend of mine was, top of his class at MIT, and went into the Air Force and got to be head of flight test for the F-22 program. Well, I don't know if you've ever seen the F-22 fly. That thing is stinking ridiculous. I mean, it almost does unnatural acts. It'll go up and it'll hover, and you can twist. I mean, it just does ridiculous stuff. And I went up to Edwards Air Force Base with my son, and he was showing us around. And the guy was giddy happy, right, with the cool stuff that he got to go do. And I've had wonderful opportunities to play with a lot of cool toys in my career. Almost fairy book-like, fairy tale-like. I just have had so much fun. When I got out of college, my first job was trying to model Soviet-era rocket systems and taking them to Brookhaven National Lab in New York and zapping them with high-energy protons and getting them to blow up. I mean, how cool is that? One of the really fun projects I got to work on back in the 90s, it was a reusable rocket. That thing's 40 feet tall. It's hydrogen oxygen. It had four engines on it. And we flew that thing up. It would hover. This is actually a photo from the New York Times. But it would go up, it would hover, it would kind of twist around. The idea was to have this thing to fly up to space, re-enter, swing around and land. But we were landing rockets on its tail back in the early 90s, right? Now our good friend Elon Musk is getting a lot more credit for it because he's doing it now and people think it's, with my water here, and people think it's new, but that's stuff that we were doing back in the 90s, and it was a great amount of fun for me. I was director of flight test for that program. Spent 3 years roaming around the desert flying rockets. We actually blew it up a couple times. How cool is that? So I was involved in a satellite. One of the companies that we put together was Satellite Communications, and we had communication facilities around the world to talk to a variety of satellites, many of which were NASA satellites, Department of Defense satellites. We got a call from NASA one day that their Galax satellite had just captured, for the first time in the UV spectrum, a supernova. And they captured it on board the satellite, and their ground equipment had faulted for some reason. They don't know why. And they were going to overwrite the memory if they couldn't download that imagery, that imagery down to the ground within 2 or 3 hours. So they called us in a panic. We were able to pull that data down, right, for NASA through our system, which is just kind of a cool thing, right? We were able to really kind of help the world move forward with that kind of data. We had another experience where a classified government satellite ran into trouble, and the Department of Defense calls us and said, hey, what can you guys do to help us? And sat around and chatted for a little bit, and it was a highly classified mission. So the Marines came in with racks of equipment, and the Marines stayed there 24/7 to guard the equipment so no one could see it or touch it. But we plugged it into our network of ground stations, and we're able to, help salvage the satellite. So it was really, really cool. Built facilities in Hawaii, in Australia, in Alaska, in southern Chile, in northern Sweden. So again, got to play with cool toys and interact with a lot of cool stuff. Another great opportunity I had was building satellites. They mentioned that I worked on these satellites that very high resolution imaging satellites. We not only got to build the satellites, but we got to build the facility that the satellites were in. We built the clean room. We built all the test equipment. And it was just so much fun, just going to work in the morning, right? I had my office. I was the CEO of the company, so I didn't get to play with the toys too much. In fact, they didn't even really want me in there very often. But I did go in there anyway. But I had my office right next to the clean room because I just loved to be there, right? And it was so much energy and all the excitement, and lots of challenging problems. But hey, I've got my name on some satellites floating around space, and that's pretty cool. So again, as engineers, we get to play with cool stuff. And so think about what it is you like to play with and the cool stuff you want to play with, and you can pretty much do anything, whether it's designing chipsets, whether it's managing massive facilities, whether it's building satellites or cars or fighter jets or whatever floats your boat. You have the chance and the opportunity to go do that when you're passionate about it, right? When you're passionate about it. Next point I want to talk about is really maybe one of the more important is managing your career, right? That as an engineer, it's really important that you kind of know and begin to learn what it is you want to do when you kind of your area of focus. Because people like me are dying to help people like you, okay? Because you guys are the future. You're a lot smarter than I am. You're more capable than I am. You're probably harder working than I am. And I want to do everything I can to help you succeed. But I can't help you succeed if you don't know what you want to do. I have people come to me and they say, hey, I'm really interested in an opportunity. Okay, well, what do you want to do? I don't know. I can't really help you, right? So you need to think about what you're passionate about. And to do that, you need internships. You might have to be changing jobs. You might try different things. For example, one summer I worked in a planning department of a Navy base, right? Boring, hated it. The next summer I worked as a software engineer, thinking, hey, that's the new up and coming thing. You know what? I sat there in front of a terminal. Everybody was typing the keyboard. Lunchtime would happen. They'd open up their drawer. They'd have their sandwich. They'd close the drawer. I mean, I'd had no interaction with anybody. I hated it, right? And I just realized that is not for me. So it's kind of through a process of getting some work experience what I realized what I like to do. But you have to take charge of your career and manage it. And there's a couple points I want to share. If you can do engineering and technology, you can do just about anything, right? It's a great foundation. I remember I had a robotics professor at BYU, my senior year, who used to talk about that. I thought, well, really, can you do anything? And he was kind of right. I had classmates that went to med school, they went to law school. There's a wide range of things that you can do. And in a lot of cases, because you have an engineering degree, they kind of put you to the top of the heap. I mean, I had a job offer from the FBI and the CIA coming out of school. And typically to get a job at the FBI, you had to have 2 years work experience. But because I was an engineer, I got to the top of the heap. So there's a lot that you can do. So think about what it is you want to do and chase your passion, because you have the ability to do that and take advantage of that. Next point. Hard work is really important, as is grit. They define grit as perseverance and then some, right? And that can overcome just about any obstacle that you face. There is one, however, that doesn't overcome, and that's hubris, right? Which you guys know what hubris is, right? It's excessive pride, right? And I've worked with a lot of startups. I've worked with startups that were founded by college students. And hard work is really important, but you kind of get caught up in what you're able to do and not wanting to listen to others. That's a fatal flaw, all right? So just think about that in your career, work really hard, right? But also be open to the inputs of others. Back to kind of that design process, embrace input from others, embrace third-party reviews, embrace critical thinking of critical analysis of what you're doing. It really is going to make you very, very successful and help you have more joy in your journey. When I got out of college, I'm a Southern California native, born and raised in Southern California, and actually went to school at University of California at Davis for a couple of years before I went on a mission. Anybody go to Southern Chile? Chile Osorno mission out there? No one? Oh, there's one. There we go. Good. There we go. Okay, fellows, Chile Osorno missionary. I then came to BYU, and I had lots of job opportunities, and I think I had 5 or 6. My wife and I didn't really want to move to California. I'd lived there. I wanted to go somewhere else. But frankly, the best job opportunity I had was in Southern California, kind of the place I least wanted to go. But it was with a lot of really smart people. And I kind of was thinking, these other places I know I can do really well because I clearly was going to be one of the brighter lights in that organization. This one over here, I'm not going to be such a bright light. In fact, I might be one of the dim bulbs. But they're really going to push me. And after praying about it, we decided, let's take that job where there's a lot of really, really smart people. That was probably the best career decision maybe I made, that first one. Because those people were so smart and had so many things that I could learn from them and sort of pushed me that it was a growth opportunity. So if you find yourself in your career, right, and you're kind of looking around thinking, man, I might be the smartest person in the room, time to make a change, okay, time to move on. If you feel like you're not growing, time to move on. I was working at Phantom Works of McDonnell Douglas, and my boss was one of the astronauts that walked on the moon. I mean, this guy was thinking genius. And there were times when I kind of got bored, and I started looking around, had a number of other job opportunities, and I was kind of stuck with the one I did. And it just came back just the quality of the people that I worked with. And he ended up retiring and wanting to do some entrepreneurial stuff, and so he asked me to go along with him, which then enabled me to expand my career immensely and gave me great opportunities to grow and develop. So again, think about that. You don't want to be the smartest person in the room. The other, I think, important part of planning your career is there's a big difference between 30 years experience and 1 year of experience 30 times over. And that's something that you have to manage. You have to always make sure that you're growing. I actually heard that when I was a student at BYU 30 years ago, sitting where you're sitting today. We had a vice president from Honeywell come and talk to us, and that was a piece of advice that he gave us. And at the time, I didn't really understand it, but I sure do now, because you run into people that are late stage in their career, and they just don't have that much to offer, right? They're not really current in engineering anymore. They've kind of let their skills lapse, and although they've been at it for a long time, they don't really have the ability to be productive, and they haven't had the career growth that they've had. So if you're in a job, you start getting stagnant, looking around, maybe you're the smartest guy in the room, or if you just feel stagnant, time to leave, all right? So those are some things that I think would help you as you manage your career and think about it, to have joy in your engineering journey. And I guess I forgot to push that button, but that's the one. There's a big difference between 30 years of experience and 1 year of experience 30 times over. So the last point, I've got a couple more minutes here, that I think is really important, and we can talk about it in a religious setting, is the importance of prayer. So you've all read Alma 34, right? Who wrote Alma 34? Do you remember? Amulek. Good, right? And what did Amulek tell us to do? Pray over our what? Pray over our fields and our flocks. And how often? Like daily. So I can tell you that in my career, I've had a number of milestones that I think about, and I was contemplating putting these thoughts together. There's probably been 5 or 6 milestones where if I'd gone this way, I would have missed so many opportunities. I was mentioning I was working for this astronaut, and I was, kind of getting a little bit bored. I had multiple job opportunities. My wife and I had some, they seemed on paper to be great jobs and more money, more responsibility, better title. Like, yeah, let's go do this. And you pray about it. It was like, God, we just should stay here. It was really frustrating, Another one came by, we prayed about it. We should just stay here. And, it turns out those were like, well, it was divine intervention, right? I can tell you experiences. Last time I spoke to the engineering college, I talked about, just an important contract and how to bid an important contract, and got an answer to that. A recent one, my wife and I, we had 3 kids at home, and I had sold a company, and I kind of had, some freedom to do what I wanted, and I got approached by this venture fund to run a technology company up in the Bay Area. It would require us to move, right? The company was a frat house. It was kind of a mess. It did not really fit my culture to somewhat. I knew I was going to have to make some significant cultural changes if I took the job. I was serving bishop at the time. I thought, there's just no way I can leave. It can't happen. And they kept sort of coming back to us. And so we decided, well, let's pray about this thing. And it got to the point where it became perfectly clear that's what we needed to go do. And once we made that decision, Pam and I felt like something was pushing us. Like literally, we were being pushed to get up there and take this, pretty high risk job with a lot of family disruption. Hey, but it turned out to be a fabulous thing. And I think the other comment, I got just a couple more minutes. In your career, it's not all about you, right? It's about your family. And my wife and I have learned that whole concept of by the mouth of 2 witnesses or 3 witnesses, right? The truth will come. When we pray about stuff, we always get the same answer. So in these big decisions, you should pray with your wife, right? And you guys should come together on those things. And you should both get that same answer. And when you both get it, you're on the right track. If you don't both get it, you're probably not on the right track. But I would counsel you to really think and pray about your career opportunities. And I think those are the key messages that I want to deliver this morning. Is I've had a fantastic career. I've been able to, I think, make an impact on technology, make an impact on science. I've been able to provide a living for lots of families. I've been able to provide for my family. We've had steady employment. I've been able to see places around the world. So congratulations to all of you for the great choice. And I hope that you have as much joy in your engineering and technology journey as I have. So thank you very much.